Welcome to solverfy.
We're told that the centroidal polar area moment, a JC bar, I'm going to call it I here because if you continue on in this book, you realize that the letter J is used for mass moment of inertia. And I taught classes in mechanical engineering where everybody, by the time they were juniors, were confused about area and mass moments of inertia and J and C and everything else and using the wrong thing in the wrong place. So I'm going to call it isobar. And that's what it is. If you have IX, IY, then this is IR. So IR of the 24 square inch shaded area is 600 inches to the fourth. Determine the polar area moments IRB and IRD of the shaded area, knowing that IRD equals to IRB and D equals 5 inches. All right, so we're given our information here about the cross section and the centroidal properties. We are given this information about the polar area moment, about D, how it relates to that about B, and then our distance D5 from the x-axis down to points B and D. We can write IRB as the polar moment, the polar area moment about the centroid plus the area, right? So the area, and then plus the distance squared between points C and point B, and that is just A squared plus D squared. Now we can write the polar area moment about D as the polar area moment about the centroid C times the plus the area times the distance from the centroid to point D, which is 4A squared plus D squared. Now we can solve these two. We can solve these. So we got two equations here. We can solve for we can solve for A. We have two equations and two unknowns. We know, actually we have two equations. We have three equations and three unknowns right here. So we can solve for A. That tells us that A is 5 inches, like as is D. And we can then solve for our area moments about D and B, and we get that if we plug in that A is 5 here, we get that that's 3,600 inches to the fourth, and obviously this one is half, and that's 1,800 inches to the fourth.